All right, so this is a retrosynthetic problem. So where you have to like work backwards to get back to the starting material. So one of the first things you need to do, and I did this on the example, this is from North 13 2019 test. I actually numbered the carbons for you, so I let you know where things are at. So be aware of that, which also should direct you. First thing to notice is that you've added 1, 2, 3 carbons. So you want to write here, add 3 C's, which of course then makes you think of the only way you know how to add carbons, right, involves Na, NH2, and a step 1, it's a plus and a minus. And then however many carbons you want to add, in this case you're adding 3 carbons. And it looks like the 3 is this 3. So the electrophile needs to be on carbon 3. So you need to add something like this. And that's step 2. The other thing you should notice here is the stereochemistry relationship between the chlorines and the H's. The H's are, right? H's are syn. That should tell you about which kind of methods have you know to add H's syn. So that'd be Lindlar's catalyst or H2 palladium on carbon. Those are 2 ways to add H's syn. The other thing you should notice, the Cl's are anti. So what does that tell you? You're probably gonna need to do a halogenation, right? That's what that would tell you too. You could write that down even then. So these are the things I would write down, like notes to myself. These are what earn you points. You should do these kind of things before you even start worrying about what happens next. First step backwards in all of these, more often than not, right? First step backwards is there was a pi bond, right? We've been doing additions. So if we end up with no pi bonds in the final product, one step back had a pi bond. You can do it a couple different ways. Let's do it this way. So that means going forward, I must have added the hydrogens. One step back from this. All right, there's carbon 1, 2, 3. Would probably be an alkyne, right? Again, adding a pi bond back. One, 2, 3. And then one step back from this would actually be that. All right, so if you look here, this is where you made that bond. All right, so going forward now, step 1, the forward arrow, step 1 would be deprotonating the terminal alkyne. And that's number 3. There's an H there. You can always draw it in if you want to. And then I need to add how many carbons, right? This is that 3 carbon piece. 1, 2, 3. So I need to have an electrophile. Step 2. That I can bond to. If you want to number these carbons, you can number them 4, 5, 6. 4, 5, 6. So 3 and 5, and you have a bond. Going forward from here, that's just straight Cl2. No solvent, 1 equivalent. You need to say 1 equivalent. So you want to stop it at 1 equivalent. And the last step here would just be H2, palladium on carbon. That's going to have the syn addition of the 2 H's.